Good morning, Miss. Here I'm gonna explain about aircraft flight control system. But before I explain about all of them, I wanna introduce myself. My name is Alfredo Simanjuntak, ID number 200500098 class BID 1B, Department Aerospace Engineering. Alright, flight control. Flight control is one of the systems in an aircraft to control the aircraft during flight. Flight control is divided into three groups, namely 1. Primary flight control or mainstream includes ailerons, elevator, and rudder. 2. Secondary flight control includes tape. And 3. Auxiliary flight control or steering edge includes flaps, spoilers, speed brakes, slots, leading edge, slot, and sledge. And number 1, primary flight control surface. The primary flight control surface is the main steering wheel on the aircraft. This main radar is very important to make it easier for pilot to fly the plane. Primary flight control is a collection of three main components that play a role in moving the aircraft when the aircraft is in flight. These three components work on each of its own axis or imaginary lines that stretch straight or axis, namely the rudder on the vertical axis, elevator on the lateral axis, and aileron on the longitudinal axis. A. Aileron, located on the wing, an aircraft control surface when they roll, moving the longitudinal axis or the axis that extends from the nose to the nail. Aileron are controlled from the cockpit by means of a control stick. The type of stability that the aileron does is to stabilize the aircraft in the lateral direction. The movement of the aileron is reversed between left and right, deflecting up or down. How do aileron work? And this is the picture of aileron. Up aileron, deflection. Down aileron, deflection. The picture on the right is the picture of the plane seen from the tail. If you wanna roll or bang or roll to the right, what the pilot does is move the control stick or steering lever to the right so that mechanically there will be a movement where the right aileron will move up and the left aileron will move down. On the right wing, where the aileron is up, there will be a reduction in the lift or lift force. This is because the raising aileron causes the speed of airflow on the top surface on the wing to decrease, or because ideally the airflow above the airfoil is faster than on the pattern surface, resulting in the lift, so that the right wing loses lift or lifting force, which causes the right wing to go sorry which causes the right wing to go down, while on the left wing the lowered ailerons cause air pressure to accumulate and cause the left wing to rise. This first, if the pilot wants the plane to roll to the left, aileron are located on the right wing and left wing. The aileron is the counterplane when the aircraft rolls. The aileron moves on the longitudinal axis, or the axis that extends from the nose to the nail. The type of stability performed by the aileron is that stabilizes the aircraft in the lateral direction. The aileron are controlled from the cockpit using a control stick. The movement of the aileron is reversed between left and right. The aileron are deflected up or down. B. Elevator. Situated on the horizontal stabilizer is a control surface when the aircraft is pitched or picked up or down, moving the lateral axis, or the axis that extends along the wing. The elevator is controlled from the cockpit by using a control stick. The type of stabilization that the aileron does is stabilize the aircraft in the longitudinal direction. Simulation simulate nose movement of the elevator between left and right, deflecting up or down. How do elevators work? And this is the picture of elevator. Up elevator, airplane nose raises. Down elevator, airplane nose drops. If the pilot wants the plane to pick up or down, raise and lower the nose. So what is done is to move the control stick on the cockpit forward or backward. If we want to pick up or nose up, then the pilot will move the control stick backwards or toward the pilot body, which will get a response by going up an elevator simultaneously with the rise of the elevator. There is a direct in the aerodynamic force of the aircraft, which presses the tail down so that the nose will rise. Conversely, if the pilot wants to pick down, the control stick will be moved forward, which will make the elevator move down so that the tail gets a force that pulls up and causes the nose to drop. The elevator is located on the horizontal stabilizer. Elevator is the control plane when the plane is pitching up or down. The aileron move on the lateral axis, or the axis that extends along the wing. The elevator is controlled from the cockpit using a control stick. The type of stability that the aileron does is stabilize the aircraft in the longitudinal direction, simulate the news movement of the elevator between left and right, aileron deflect up or down. See rudder, located on the vertical stabilizer, an aircraft control surface when doing yaw, moving the vertical axis or perpendicular to the longitudinal axis of the center of gravity of the aircraft. The rudder is controlled from the cockpit using the rudder pedal. The type of stabilization the type of stabilization that the aileron does is stabilize the aircraft in a directional direction. The movement of the rudder is deflected to the left or right. How do rudder work? And this is the picture of rudder. Yaw, lift rudder forward, lift rudder, aerodynamic force. Rudder work with an intermediary mechanical system called the rudder pedal, like the brake or gas pedal on a car. There are two pedals, left and right. Is for left and right yaw movement. If the pilot wants the plane to yaw to the left, the pilot will press or step on the left rudder pedal. Mechanically, it will mean the rudder will deflect to the left. What happens is that aerodynamic force arrests that press the deflected rudder surface so that the tail will move to the right and the nose will move to the left. Then the plane will yaw to the left. On the other hand, if you are going to yaw to the right, you are stepping on the right rudder pedal. The rudder is located on the vertical stabilizer. Rudder is the control area when the aircraft is to yaw or turn. The rudder moves on a vertical axis or the longitudinal axis is perpendicular to the center of gravity of the aircraft. The rudder is controlled from the cockpit using the rudder pedal. The type of stability carried out by the rudder is to stabilize the aircraft in a directional direction. The movement of the rudder is deflected to the left or right. Secondary flight control surface. Secondary flight control surface can be considered as an additional control area that aim to assist the performance of the primary control surface and aircraft movement when flying, taking off, or landing. Include in the secondary flight control surface are various tabs, namely trim tab, servo tab, anti-servo tab, balance tab, and spring tab. Aircraft tab, and this is the picture. Rudder trim tab, elevator trim tab, aileron trim tab. Definition of the tab is a small auxiliary airfoil heightened to the control surface or as the trailing edge to help stabilize the aircraft in flight. The tab serves to edges the pressure that must be released when positioning the incline or head clinch. The tabs are arranged in the cockpit by wheels that can be adjusted fore and aft. In light or small aircraft, the above mentioned control surface are driven by pilot power, as control surface is connected directly to the control column or steering wheel by a series of cables and pulleys or rods. In a control system, the control column can move the control surface, but the control surface can also move the column. This is called reversible control type of tape. Nose down trim, elevator, trim top up, elevator down. Nose up trim, elevator, trim top down, elevator up. Rudder trim top, elevator trim top, aileron trim top. 2. Servo tap, often called the flight tap. It is used primarily for large or wide main control surface which work to assist the movement of the control surface and hold it in the desired position. Only the servo tap moves in the response to the movement of the cockpit control, where the horn of the servo tap is independent of the pivot of the height axis of the main control surface. The airflow pressures on the servo tap will move the primary control surface therapy, reducing the power required for the pilot to move the primary control surface. 3. Anti-servo tape. Anti-servo tapes work in the opposite way to servo tapes. The anti-servo tapes serve primarily to make weight control in the pilot field and also to increase stability. In other words, the interserval tape serves to reduce the pressure load on the string well and help the stabilizer to stay in the desired position. For balance tape, the circuit on the balance tab is designed in such a way that when the main control surface moves, the tab moves in the opposite direction. So the aerodynamic force acting on the tab help move the main control surface. And this is the picture of balance tab. Balance tab when elevator move up. Balance tab moves down. 5. Spring tab. 5. Spring tab works like a hydraulic actuator, helping to move the primary control surface. The construction consists of a spring arrangement and other mechanical circuit. In some aircraft, spring tabs are attached to the trailing edge of each aileron and are driven by the force of a spring-pushed pull rod which is coupled to the aileron control linkage. Activation control of tape. A simple control. A simple mechanical cable can be found on the Cessna C-152 aircraft. Cables in some aircraft are replaced with a rod rouge. The control column can be moved by raising and lowering the elevator. And this is the picture. Aileron control, elevator control, rudder control. B. Posted control system. This is a simple post system. When the pilot moves the column, tension in the cable or rod also open. A valve that releases pressure from a hydraulic or pneumatic pump by expanding a slave cylinder that helps equate the controls. The control column can be moved by raising and lowering the elevator, but this requires more force. See, fly-by-wire system. There is no mechanical connection between the column and the control surface in the fly-by-wire system. There is a sensor on the control column which transmits the column position to the actuator. The actuator then moves the control surface to the appropriate column deflection position. This system is not reversible, or the control column will not be moved by moving the control surface. This system is much lighter than the post system and is used on all large aircraft today. D. The control system tab. Initially, large aircraft designer avoided using post controls as as described above. For example, the DC-9 aircraft used the actuated control tab. On the system control tab, the pilot only moved the small actuating tab on the large control tab. The power generated by the next tab moves the main controls. This is how trim tabs work the same way. Therefore, you can think of these systems like trim tabs if they are connected to the control wheel instead of a separate control system. Note that in the tab control system there is no direct connection between the control column and the control surface. And this is the picture. Downspring, stabilizer, elevator. 3. Auxiliary flight control surface. The auxiliary flight control surface includes flaps, spoiler, speed brakes, sled, leading, edge, flaps, and slots. The auxiliary group is divided into two groups, namely the leaf increasing group and the leaf decreasing group. Included in the leaf increasing group are flaps, trailing edge, and leading edge slots. And this is the picture. Fixed slot, automatic slot included in the leaf the deck racing group are speed brakes spoilers. Types of flaps consist of 1. Plain flap, 2. Split flap, 3. Fowler flap, and 4. Slotted flap. And this is the picture. Basic section: plain flap, split flap, slotted flap, Fowler flap, slotted forward flap. Thank you, Miss.